Hello, welcome to a video from anandbapu.com. Today, I will be showing you the 4 geometric transformations. The first geometric transformation is known as a translation. So if we have an xy plane, and we have a point, let's call this x, y. If we want to move that point to the right, a units, and up, b units, we end up with the point x plus a, y plus b. And this makes sense because if you move a units to the right, you're moving a positive x units. And if you move b units up, you're moving b positive y units. Same way, if you move b units down, then you end up with x plus a and y minus b because you're moving b units in the negative y direction. And now, if you move, same way if you move left a units and up b units or down b units, you'll end up with x minus a and y plus b or y minus b, depending on whether you go up or down. The whole thing is that right a means x plus a if you go to the right. X minus a if you go to the left. Y plus b if you go up. Y minus b if you go down. So basically what that means is a is positive for this, a is negative for this, b is positive for this, and b is negative for this. So the general formula for translation is x, y becomes x plus a, y plus b. This takes into the fact that a can be positive or it can be negative, and the same with b. So now when we have the point 2, 3 is translated 2 units to the left and 4 units up, what point do we get? So let us draw this point. So we have a coordinate plane with 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Same thing up. 1, 2, 3, 4, 5, 6. Same thing to the left. 1, 2, 3, 4, 5, 6. So you end up with the point 2, 3. So 1, 2, 1, 2, 3. So here's your point. So translated 2 units to the left. So 1. So now we get here and 4 units up. 1, 2, 3. Draw a 7th marker. Up. So what do we get? Our final point is 0, 7. From 2, 3, we went to 0, 7. So you could have used the formula too. Remember, 2, 3 becomes 2 minus 2 and 3 plus 4, which equals 0, 7. So if you have to reflect a point across the x or y axis, here's what you should do. So I will redraw the coordinate plane. So 1 second. So here we have the coordinate plane. If we have a point here, and we want to reflect it across the x-axis. So we know that this is y units away, because we have xy. We want to go another y unit. So this is also y units. So what do we end up? Obviously, the x unit is the same because we didn't actually go anywhere x-wise. However, the y units becomes x negative y. So when reflecting across the x-axis, your formula is xy equals x negative y. Now if we want to reflect a point xy across the y-axis, then you realize that this is x units from the y-axis. This new point should also be x units from the y-axis in order to be a good reflection. So what you end up with is negative x, because you flip the x, y. So now for y-axis, your equation is xy becomes negative x, y. That's it for reflections. So when you have the point 3, negative 6, which is, say this is 3, so you have 3, negative 6. So you have the point 3, negative 6. You want to reflect that across the y-axis. So this point is 3 units from the y-axis. So we need to go another 3 units from the y-axis. So when you get that, you get negative 3, negative 6. It's as simple as that. If you were to use the formula, you'd get the same thing. The formula says xy becomes negative x, y. So we get 3, negative 6 becomes negative 3, negative 6. So if you have the point xy and you want to rotate it 90 degrees about the origin, whenever it says 90 degrees, whenever it says any degrees, positive degrees, it is assumed to be counterclockwise. When it says a negative degrees, it is assumed to be When it is a positive degree, it is assumed to be counterclockwise. When it is a negative degree, it is assumed to be clockwise. So when I say 90 degrees, that means 90 degrees counterclockwise, unless specifically told so. Like, unless it said 90 degrees clockwise, whenever somebody said 90 degrees, it means counterclockwise. So you end up with rotating this point 90 degrees to get this point. This point is at negative y and x. So this point is negative y, x. Now, if we were to rotate that point an entire 180 degrees, then we would get the point negative x, negative y. So we would get negative x, negative y. And now finally, if we were to rotate it 270 degrees, or negative 90 degrees, we would get y, negative x. Y, negative x. So thus, the formulas can be written as such. 0 degrees is just xy to xy, because you're not rotating anything. Same for 360, or any multiple of 360 for that matter. For 90 degrees, or negative 270, xy becomes negative y, x. 180 degrees, or negative 180 degrees, xy becomes negative x, negative y. And finally, when you have 270 degrees, or negative 90 degrees, you end up with xy becomes y, negative x. So you have the point 3, 4. So 1, 2, 3, 1, 2, 3, 4. So you have this point, and when you rotate it 90 degrees about the origin, you will get, so we're going to take these three, so it's 3 this way, and 3 and 4 this way. So when you rotate it 90 degrees, it will be 4 this way. 1, 2, 3. That was bad. Wait a minute. 1, 1, 2, 3, 4. And 3 up. 1, 1, 2, 3. So you end up with this point. As you can see, they are 90 degrees. And so you get, finally, you get negative 4, 3. And you would have got the same thing if you used a formula. If you had xy to negative y, x, and we would have gotten 3, 4, 2, negative 4, 3. So if you have a point, xy, and you want to dilate it about the origin with a scale factor of n. So let's just say the distance from this to the origin is a. So the distance from here to here is n. Not n, sorry. From here to here is x, and the here to here is y. So you want to dilate this. Why am I drawing so bad? You want to dilate this nx and ny. So now you end up with a distance from the origin. So you end up with nx and ny. So the formula is xy dilated with a scale factor of n has the equation nx ny. Okay, so you have the point 4, 5. So this is 4 and this is 5. So we want to dilate by a factor of 2. So we want to go 8 and extend this and get 10. So the distance at this point was, if you wanted to do the Pythagorean theorem, you get 4 squared, 5 squared. So this is not necessary. I'm just doing it because I want to get square root of 41. So, but from here to here, the distance is 2 root 41. So obviously it's double the distance. So we did it properly. So now, now we get the point 8, 10. If you used the formula, you would have got the same thing. xy equals nx and y. 4, 5 becomes 2 times 4 times 2 and 2 times 5, or 8, 10. Thank you for watching this video. On the left will be a subscribe button. Please click and support me. And on the right are 2 more videos that you can watch.